सर एक बार क्रॉस चेक करने लगा।
कर लो क्रॉस चेक कर लो।
सर 0.0023 आ रहा है।
0.00 ठीक है. You can see that the values are very close to 0, isn't it? So the my point is over here is like you see the value of y is coming very close to 0. And how many iterations it took? It took only 2 iterations to get to that particular value, because you see it is 0.002. And if you refer the values of the earlier method, we are nowhere closer to this. That is, last time if you see it was 0.01, and in the regular falsy method it was 0.02. Okay, but here if you see it is 0.002. And how many iteration it took? It took only 2 iteration to reach this particular value. Okay, so I hope you have understood how fast this method is, isn't it? Still, if you want, you can continue this. So I'm just continuing this with 1.2006. Okay, and the this value will be 0.00206. Okay, so now can you please tell me f dash of x and another value of x1? I'm sure it will be 1.2 only. Sorry.
3.4428.
Okay, and how about x1 then? 1. Okay, and if you calculate the value of y1 for x1 as 1.2, I'm sure this will be 0. Please cross check. Is it 0?
Yes, sir.
Okay, good. So now you can see, since the y value is 0, we have actually found out the correct root. Okay, so this is the final root, this is the final answer, and we have just obtained this in just 3 iterations. Okay, no more iterations are needed. Even if you go for one more iteration, for example, if you substitute this as 1.2, y value will be 0. You will be getting some value of f dash of x. Okay, some value. But if you see the Newton Raphson equation, x1 is nothing but x1 minus this term, and here in the numerator term there is a y0. Since y0 is 0, this entire term is going to become 0. Now you will always get x1 value as x0 because your y0 is 0. So even if you go for one more cycle, you are going to get the same values again and again, again and again. Okay, so here you can stop because the y value is 0 and this will be your final answer. So your root number 1. Okay, so there are 3 roots. Okay, so root 1 will be your 1.2. Okay, I hope this is clear to everybody.
Yes, sir.
Okay, now let us quickly take another example. Okay, example 2, which we have done in the previous class. Okay, I think in previous class we have taken y equals to x e raised to power x minus 3. Okay, so the equation is like this. This is y equals to x e raised to power x minus 3. Okay, now since this is your y, so your you can start with any of the guess root. Let us say guess root is, let us say, 1. Okay, but here you need to find out f dash of x, that is dy by dx. So now here, if you don't know or if you are not aware of this derivative, how to get the derivative of some expressions like x into e raised to power x, if you don't know it correctly, then you won't be in a position to solve this problem using the numerical or using this Newton Raphson method. Okay. Yes, anybody has answer how this derivative will be x into e raised to power x? Anybody? क्या आता
We
है?
have to apply UV method.
हाँ,
X
but
into e power x minus e power x.
so this is x into e to the power
Power
x minus
minus power x.
e to the power x. Okay. Yes, this is the correct one. But if you don't know this, then this method is not suitable for you. Okay, you need to have good knowledge of mathematics. You need to know how the first derivative is calculated. Okay, so now let us once again quickly go with the solution using the Newton Raphson method. So let me add some tables over here. Okay, so let me add a table over here. Say I need 5 columns. Okay, so let us say this is x0, this is y0, and this is f dash of x. Okay, and then you can have x1 and you can have y1. Okay, so I'm starting with the guess root as 1. Okay, so can anybody tell me what will be the value of y1?
Sir, in that f dash equation, positive sign है ना sir? हाँ sir, positive है.
Okay, yes, yes, yes,
हाँ sir, plus sign है. Sorry.
yes, yes, yes. Okay, thank you. Okay, now can you tell me what is the value of y when x value is 1?
Minus 0.2817.
Okay, let me write down minus 0.
817.
Okay, and what about f dash of x? That is x e raised to power x plus e raised to power x. You can also rewrite this as e raised to power x, x plus 1.
5.4361.
5.4361. Okay, so
65.
65. Okay, 65. And your Newton Raphson equation is like this. It is x1 equals to x0 minus y0 divided by f dash of x. Okay, so use this expression and please tell me the value of x1, please.
1.0518.
0518. And what will be the corresponding value of y1?
0.0110.
So you see it in just one cycle, you have reached the value of x such that the corresponding y value is 0.01. Okay, so you see how accurate and how fast this particular method is. Okay, still let us go for one more cycle. So I'm just putting the same value, that is 1.0518, and your corresponding y0 will be 0.01109. Okay, so please tell me what is the value of f dash of x with this new value of x0 and y0.
Sir, f dash of x is 5.8738.
Okay, someone please cross check.
Yes,
Okay,
sir.
good. And how about x1?
1.0499.
And how about y? Y1?
minus 0.40
405.
and 5.
ठीक है. सो आई एम श्योर इसका आंसर होना चाहिए 1.05, है ना? Okay. So if you want, you can go for 1.0499, and this is minus 0.8234. Give me the value of f dash of x, and again the value of x1.
Minus 0.8573.
Okay. Okay. And how about this one? What about x1?
1.0499.
तो उतना ही आ रहा है, 499 आ रहा है.
Yes, sir. Oh, yes.
ओके ओके ठीक है. और ये कितना है? कोई आएगा
Same here, sir.
because the values are repeating. Actually, there are some errors due to the rounding off, but ideally it should be 1.05, and the corresponding y value will be 0. Okay. So all I'm trying to say over here is this method is very very fast, and you can see with the help of both the examples how fast and how accurate this method is, because you see, as far as accuracy is concerned, the value of y for both the examples, they are very very close to 0. Okay, in fact, in the first example we have obtained the value of y as 0. Okay, and this is also very close to 0. So this method is very fast, as well as this method is even accurate as compared to your bisection method as well as the regular falsy method. Okay, I hope you have understood this.
Yes.
ठीक है.
Yes, sir.
Now there are since this method is very fast and accurate, still this method has got some drawbacks. Okay, so let me explain you the drawbacks with the help of some curves. Okay, so let us quickly see this. So for example, I have a curve which is represented by a line which is like this. Okay, so the line is going like this, right? Now as far as the procedure of this Newton Raphson method is concerned, we have to choose any point. Okay, so what will happen if you choose a point over here? You will get a tangent which is intersecting the x-axis, which will be ultimately converging towards the 0. Okay, but this choice of the point is up to you. Some of you may choose this point, some of you may choose this point, even some of you may choose this point. Okay, so if you choose this point and if you try to draw a tangent, so at this point the tangent, if you draw, you will find this tangent is perfectly horizontal. Okay, it is not at all intersecting the x-axis. इसका मतलब क्या हुआ? Your dy by dx is nothing but 0. The slope of this line is 0. Okay, especially at this point. Okay, I'm talking about this point only, because at this point or maybe other point, it may not be 0. It can be negative, it can be positive, but it will be non-zero. But at this point, if you see, the tangent is drawn horizontally and dy by dx is becoming 0. As far as your equation is concerned, x1 is nothing but x0 minus y0 divided by, here you have f dash of x, or f dash of x is nothing but what? Dy by dx. Now since dy by dx is 0, this term is going to become infinity. Okay, so now in this particular scenario, this Newton Raphson method is not able to give you solution, the even if you write a program for this, the program is going to get hang, and manually you won't be able to do it because this second term is going to become a infinity. So in such case your Newton-Raphson method fails to give the solution. Okay, so this is one of the major drawback of this particular method. Okay, have you understood this everybody?
Yes, sir.
ठीक है, ये एक ड्रॉबैक है. ठीक है. Now the second drawback. Okay, let me draw another curve for you. This is the first drawback. In the second drawback, okay, so let me draw a curve. Say for example, uh, ओके, और रादर थोड़ा सा अलग तरीके से बनाते हैं. सो लेट मी ड्रॉ कर्व विच इज लाइक दिस. Okay, so this is a curve. Okay, now you can choose any point. Okay, so for example I have chosen uh, this point. Okay, so as far as this method is concerned, what we have to do is we have to draw a tangent. Fine, so I am going to draw a tangent, so I am calculating the slope. Now this slope is non-zero. Okay, इसका मतलब क्या हुआ? This will be intersecting the x-axis. Okay, so here you are going to get another point, and you will find that this y value is non-zero. Then you will be reaching at this another point. Okay, but when you reach at the second point and then if you try to draw a tangent, then it is becoming horizontal. Okay, up. Now what is going to happen over here is once again the value of slope is 0, that is dy by dx is equal to 0, and again your x1 equals to x0 minus this y0 divided by dy by dx. So this going to become infinity, right? So the same drawback is there, but this point or this situation may come while going for the iterations. Okay, so in the first case it was directly in the assumption case, but in the second drawback is, so this situation may come anytime within the iterations. Okay, so you may have started with some guess root, you are starting the problem, you are going for one iteration, second iteration, third iteration, and suddenly you will find dy by dx is becoming 0, and after 3 iterations or maybe 4 iterations or maybe even 10 iterations, you are not able to get the correct solution because the slope of this particular line is becoming 0. Okay, so this can happen in the middle also. Okay, I hope you have understood this. Yes.
Yes, sir.
Okay, so this can happen anytime. Okay, so in both the cases, whether it is becoming 0 at the beginning or maybe at the end, so in this case these scenario whatever I have told you, they are very very rare. Okay, very rarely you will find this particular scenario because most of the time your values are there in decimals, and since they are in decimals, so ultimately they are going to get converged. Okay, anyway, so this is another scenario where this Newton-Raphson method is going to fail as far as the solution is concerned. Okay, now there is one more scenario. Okay, so I have a equation which is like this. Okay, and we have say अब इसको मैं कैसे बनाऊं? Let me try this. Okay, और रादर इसको थोड़ा सा हम्म, अलग बनाते हैं. रुको, फिर से बनाते हैं. Mhm, 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 mhm. Let me do it one more time. Okay, let me draw a straight line over here. Okay, and mm, Okay. um, Fine. uh, we'll have a curve like this. That's much better. Okay. Now, try and understand this. Okay. So, for example, you have a curve which is y as the function of x. Okay. So you have started with this point, for example. Okay. So this is your p1. So what you have done, you have drawn a tangent like this. Okay. And this tangent is intersecting over here. Then you have got you have got another point. Let us say p2 over here. Then in the p2, what you are going to do, you are going to draw one more tangent over here. Okay. And this tangent is going to intersect this axis, and again you are going the same point. Okay. So from p1 you are generating p2, and from p2 once again you are going back to p1. Okay. So this sequence goes on and on and on, and this is not going to end anytime. Okay. So from p1 you are getting p2, from p2 again you are getting p1, because the you have chosen a very wrong point. Because of that only it is shuffling. Okay. So this is also a very very extremely rare scenario, wherein once again your Newton Raphson method is going to fail to give the solution. Okay. Have you understood this? Pretty simple. Okay. So these are the three major drawbacks of this particular method. And whenever probably you may never face this particular scenario, but still, just in case if you face this scenario, either your tangent is becoming horizontal, or maybe your roots are getting repeated. In that case, what you have to do is you just start fresh and you choose a different value. Okay. So for example, you have started with a guess root of, let us say, 1. And after starting with 1, you are getting the horizontal tangent. So in that case, what you can do is you can scrap the entire solution, and you can start fresh. In place of 1, you choose either 2 or maybe 3 or even 1.5 or even 1.1. Doesn't matter. Okay. You just change the guess root, you start one more time, and I'm sure in the next trial you will be able to get the correct solution. Okay. So these are the major drawbacks of this method, but still, without this drawback also, this method is very widely used in various computer programs which are still being used as for the structural analysis purpose. Okay. So Newton Raphson method is very useful, and I'm sure some of you, if you are going in the software field, especially the softwares which are related to civil engineering, in that case you will have to use this particular method to get the correct roots. Okay. Okay. Are there any queries? Yes, students, are there any queries, please? Okay. In examination, most of the time numericals are asked. Okay. But still, in some of the papers, you may find some theory is also asked. Okay. Theory like you have to derive the expression for the Newton-Raphson method, or you may have to write a short note where you have to compare the regular falsi method with bisection method and Newton-Raphson method. Okay. So you should be in a position to write the correct answer. Okay. And you may have been asked like, what are the advantages and what are the disadvantages of Newton-Raphson method. I have already explained you all the advantages and disadvantages, but you have to write them properly in the examinations. Okay. Is it clear to everybody? Okay. So what I'll do, for the time being, I'm stopping, but probably today evening or by tomorrow evening, I'm going to post first assignment in the Google Classroom. So I'm expecting that everybody should submit the assignment within the time. Okay. All right. So you